Okay, thank you everybody for coming. My name is Moisir. Oh, I skipped Jeremiah in the intro, but I'll let you introduce yourself right after I'm done. My name is Moisir Sapareda. I'm the research data librarian here. I'm part of Research Data Services. We'll talk about Research Data Services in a second. And the head of Research Data Services is my helper here today, Jeremiah. Do you want to say anything?
Sure. Well, I'll tell you my history with programming languages. I do have, I've dabbled with quite a few languages, including Python. I used R. Even played with JavaScript and Java. But mostly, right now, I'm in meetings. So I'm actually looking forward to today. This looks fun.
Yeah. So I have this little presentation here. So the way that this is going to work is, first off, you can follow along the presentation. You can go to my website. You don't have to type this whole thing out. You can just type talks.moisir.com and talks, plural. And it's the first link here, day one JavaScript. So you can go to just this part of the URL and then click day one JavaScript, and then you can move around with the arrow keys back and forth. So this is a presentation that was written in Markdown, which you may or may not be familiar with. We'll talk, if you come later in the semester to sessions, you'll see more Markdown at work. But what I did is I typed up a little text document in Markdown, and then JavaScript turns it into this thing on the web that you can use the arrow keys to move around with. So this is the first page. There are some links here to the libraries, etc. The links are a little bit hidden, but they're there. When you mouse over them, things will get gray. And then I want to talk a little bit about Columbia Data Club. This is the first session that we're having in almost a year. The last session we had was in November of last year. Things are a little bit different than they have been in the past, in the sense that I'm trying something new, which is focusing on JavaScript. So not Java, but JavaScript. I'll talk about the differences in a second. And the point of Data Club is it's not entirely like the sort of like going to class. It's not about showing up, sort of turning your camera off and just listening to the professor. I'm not a professor, but listening to the professor talk for 90 minutes and then taking notes or something. What I have is about what I hope will be 45 minutes to an hour of prepared material that I'll walk you through. But we're going to get hands-on really quickly, and I have a couple silly little challenges for us to do together or separately or however you want. And then the last half hour, I encourage you to spend that time thinking about how this could be of use to you. And we can do that as a discussion. We can do that as just a bunch of Google searches. We can do that however. And that more open-ended section won't go on YouTube. It's just the prepared stuff so you're totally free. Everything will be off. The recording will be stopped. So you're totally free to participate in that stuff. So I'm a little bit sniffly today also, so bear with me if my thoughts are a little disconnected. I got a cold somehow. And I wanted to say that Data Club is brought to you by the libraries, and particularly the Research Data Services team. That's me and Jeremiah and my two other colleagues. I like to say that, and well, Jeremiah does too, if you only learn one thing in one of these sessions, it's this email, data@library.columbia.edu. If that's the only thing you learn, then we win. Because as soon as you have a question about data, whatever it is, it does not hurt to ask us. When I talk to people who don't typically work with data in their research, so like people in the humanities or something like that, we often like to say, as soon as you find yourself opening a spreadsheet, get in touch with us, because we can help you make sure that you make this spreadsheet in a way that works for you. And we have a link tree that, so just linktree/Columbia libdata, which takes you here, which just has a bunch of our links to Instagram. The videos are on YouTube, like I said, or will be. Well, old ones and new ones too. We have a mailing list. I don't know how many of you are on it. That I send emails reminding people of upcoming sessions. There's a calendar, so you can have the Data Club events show up on your Columbia calendar. Like, you can just subscribe to the calendar. Instagram, you get to see all these announcements with pictures of like pandas or whatever. And YouTube is the video. So that's all here too. Okay, I think that's about everything I wanted to say about Data Club. So, yes, so Data Club is about experimenting, being creative, and learning together. We're here to sort of try out different things and see how things are going on. And we learn about something new and then take risks as a group. Jeremiah, can you help our recent arrival with getting to the web page?
Oh, yeah, sure.
Thanks. Okay, so next is, what is JavaScript? So a couple of you have mentioned Java when we were talking beforehand, before we started, about your interests. And Java and JavaScript are not the same thing. They are extremely different. And it's kind of funny how this worked out. So Java was a language, I think, that was developed by either Sun or Oracle. I can't remember which now. But Sun and Oracle owns it doesn't matter. And this is going on the internet. I don't want to be wrong. Java was developed around 1994 or so. And Java was designed in order to be sort of the computer language for the internet. And one of the things that was amazing was that you could run these things called applets. Have any of you heard of Java applets? These were, you're all much too young for them. Java applets were supposed to take over the web, which was like a year old at the time anyway. So applets were going to take it all over. And what applets were little things that loaded inside the browser that let you do things. And a lot of sorts of the things that we take for granted now in the web, like being able to play video or even just being able to press play and get a sound out, were impossible without the use of these applets. And so Java was going to solve all these problems. At the same time, Netscape, which you may have heard of. If not, Netscape was the first sort of big browser that caught the world on fire. There were browsers before, but Netscape was the first big one. Netscape asked this guy, Brendan Eich, to write a scripting language that goes inside the browser, so that instead of launching these little Java applets, you could have little things to make text jump around or something like that. So Brendan Eich wrote the entire language in about 10 days. I think that this is like not a myth. It's somewhat confirmed that it took him about 10 days. So as a result, there are lots of problems with the language. And for a very long time, it was considered to be a toy, something that made web pages annoying because like pop-ups and all this kind of stuff, that's all JavaScript. And it all boiled down, the author of this book, Douglas Crockford, is actually a very big proponent of JavaScript, but it's a running joke that his book, JavaScript, The Good Parts, is like this thick, whereas the main JavaScript book is like this thick. So he boiled down to sort of like only use this part of the language, because there's lots of the language that just doesn't make sense, and you don't need to use it. So it's unrelated to Java. The reason it's called JavaScript was Netscape was trying to like latch on to the popularity of Java. I mean, back then I made the same mistake. I thought they were related, like JavaScript was kind of like the web version of Java or something. Totally unrelated. They look alike in the sense that the syntax is somewhat similar, but Java is a compiled language like C that you use to build complicated applications. Until around whenever Node started, around 2010 or so, or maybe even later, JavaScript was basically just something that ran in the browser. And what that means is that JavaScript is probably the most available programming language in human history. And so this is why I am a huge fan of the language and why I'm very eager to share my interest in the language with other people. So when I say it's in the browser, what I mean by that is you can think of a web page as being made up typically of about 3 things in terms of what's presented to you. There's the data in the background that a database, it talks to a database to get information. But what it presents to you is basically HTML, CSS, and JS, JavaScript. And this is a huge oversimplification, but you can sort of think of the HTML as the sort of substance of a sentence. It's the nouns, right? That provides sort of the framework. It's something like the nouns and the syntax. The HTML provides the framework. It provides the sort of building ground for the web page. The CSS, cascading style sheet, it describes how things will look. So you can have the noun would be like a block of text. So that would be HTML. The CSS would be using this font, or this color, or this size, or with this background, or positioned in this corner of the page, et cetera, et cetera. So that's kind of like the adjectives, because it provides a layer of aesthetics to just the straight content. Back in 1994, before CSS existed, you went to a web page and they all looked identical. They had a gray background. They had, whatever font you selected from your computer to render. You couldn't set the font. You could sort of mess with the sizes, but not so much. But they all looked identical. Now no web pages look the same. Finally, JavaScript is the verbs. Anytime anything happens on a web page, that's JavaScript doing it. So even if you build a web page with Shiny in R or with some kind of stuff in Python or anything like that, ultimately that Python program or that Shiny thing, what it's doing is it's rewriting the R code into JavaScript to handle the activities on the page. So anything that happens, anything that moves, flashes, pops up, all of that is done by the JavaScript. So that's why you can have a web page that is only HTML. You can't have a web page that's only CSS, but you can have a web page that's 3 lines of HTML and 1 line of JavaScript, and the JavaScript builds the entire page. Because that's among the things it can do, is it can say, okay, make a box here, make a box there, make a box there, fill it with data from here, fill it with data from there. And that we'll get into later this semester. Okay, so what do I mean by saying it's the most available programming language in history? You all don't have to install anything to use JavaScript. If you use Chrome, you just have to type F12, and you will get a console to open up. So please do this. If you are using Firefox, you have to do either Control-Shift-J or Command-Shift-J. If you're using Safari, it's a little bit more complicated, but I do have the instructions here. I'll give you all a second to do that. Oh, it won't look like this for you. Sorry, I should have been a little bit better about this. You will see something that perhaps looks like this. So this is all the HTML. All right, raise your hand if you've got something up that looks a little bit like this.
Mine is empty.
Yours is empty?
Is that right?
It would be odd for it to be empty. Go have a look, Jeremiah, please.
Oh, elements, right?
Yeah. So if you click on the little arrows here and you switch from elements to console, then you'll have the console. Okay, great. So it's empty for you. Okay, great. So this is the console. This has a JavaScript interpreter built right into it. So we can do 1 + 1 and get 2. Please do so. Or put in your own math. So the power of this cannot be overstated, I think, because Anna, you said you were writing Swift for like iPhone apps and stuff. A lot of iPhone apps are just websites that look like apps. You know, they package up, so it's all the sort of activity and whatever can be written in something like Swift, which is it's also compiled language, right? Or you can just write it as a web page in JavaScript and just ship that. So you can use libraries like Native React, I think it's called, for that sort of stuff. JavaScript is in every single browser that has been made since 1995. And for about 10 years, there was a fight over which version, which kind of JavaScript, because Microsoft made their own JavaScript, long story. But since, let's say, 2010, they have all had a very standardized version of JavaScript. And this language is in every browser. It's in a lot of apps that you might not even think are actually browser apps. Like if you have Slack on your computer, Slack is actually just a web page that looks like an app on your computer. And as a result, this is unlike Python, which you have to install, or R, which you have to install, or no, you have JavaScript right here. This is it. This is how you get to it. And this is what we'll be spending the next couple of minutes on. Okay, so the console is a place where we can mess around and start making mistakes. You can actually use the console to change the contents of the web page you're looking at. This is when I knew I should start teaching JavaScript. I don't know if I've ever told you this story, Jeremiah. I was teaching at NYU, and I was trying to show to my students. My students had been learning Python for something, and I was trying to show them something cool about JavaScript. So I opened up the NYU web page, and then opened up the console next to it, and I changed what the web page said. So originally it said something like NYU, let's learn together or something. And I changed it so it said NYU, spend your parents' money. And my students were like, that's what we want to know how to do. And that's when I because that's the other thing is that JavaScript gives you immediate results. I can't really show you how to do that here. Why not? So, yeah, I can make a little change here. I don't know how clear that is, but it said Columbia Lib Data, and I changed it to Hello from Data Club. Hello from Data Club, all of you, just like that. You obviously won't see this. This is just on my version of this page that I have loaded on the browser. But the point is it's immediately visible. And you can use the elements to immediately see how these web pages are built. Back in the 90s, that's how you learned how to make web pages, is you went to web pages you liked, you looked at the source, and you copied it, and then learned how they were doing what they were doing. Okay, so data types. So this is a little bit of a quick description of how the programming stuff works. There are, how many do I have here? 1, 2, 4, 7. 7 data types. Numbers are numbers. Other languages make big points between integers and floats, which are just decimals. JavaScript doesn't care. It treats everything as a float, whether it has a decimal point or not. Strings are text. You just put, you surround whatever you want to encode as a string of data in quotes. You get a string. Double quotes or single quotes, doesn't matter, just be consistent. Boolean is true or false, written in lowercase like this. JavaScript also has this kind of concept of truthiness, where things can be truthy even though they aren't literally true. We'll see that in action in a little bit. Arrays are collections of things that are surrounded by little brackets. We'll see them in action in a little bit. Objects are a collection of named properties, so they're like arrays but with named things, and they're indicated by the little braces. Functions are cool things that do things. I can't really describe them in any more detail than that. And null is the non-value. It can be a little bit weird because JavaScript was written in 10 days. OK, so the way we work with these data types is by declaring variables and then assigning values to the variables. In a language like Python or R, you don't have to do any real declaration. I think that it's right to say that the declaration is done during the process of assignment. In JavaScript, it's best to declare the variables ahead of time, just sort of to keep things in place. The way you typically declare a variable is using the const keyword, C-O-N-S-T, and then you assign a value to the variable with the equal sign. So if I do const a equals 1, let me see if this works. OK, great. And then I just do a, it returns me the value of 1. And if I do a plus 1, it returns me the value of 2. The newer consoles have this funny thing where they actually sort of they pre-tell you what the return value is of whatever you're doing. You can use the semicolons or not. JavaScript doesn't care. It was written in 10 days. It's generally good policy, I think, to write them, but I think that that's actually falling out of favor. I see a lot of code now that doesn't use the semicolons. Const creates an immutable variable. So I can't do now a equals 5. I get an error. So immutable makes sense for numbers and strings. For things like arrays and objects, what immutable means is a little bit not as obvious, but you can't rename a. A is going to be 1 forever. Well, until I close the web page and reopen it. If you do need to make a variable that you can change, then typically you use the let variable. And then you can do I equals I1. Well, let's do 1 plus I. So we set it to 0, and then we set it to 1. And then I can do that again. And now it's 2. It's generally, I prefer to, idiomatically, you will use const most of the time. Numbers are exactly what you'd think. I have written down here a bunch of funny things about how numbers work, but basically they work like they do. There are funny computer things. This is a great example of a problem. I once was teaching JavaScript and gave this as a homework assignment to say, why do you get this answer when you do 0.2 plus 0.1? And one of my students, bless them, said, because the computer is more precise. And I had to say, nope. This is not more precise. This is less precise. Unless you're doing financial transactions, you don't really care about this sort of stuff. So like Python, there's a nan value that's not a number, but acts a little bit like a number. And you can also turn strings into numbers with parse int and parse float. I know I said JavaScript doesn't care between integers and floats, but you can parse differently. Dates work in a completely different way. They are famously complicated in every language because humans made them complicated. Strings are surrounded by quotes. Like I said, just be consistent. You can use whichever. F-strings in Python are called template literals in JavaScript. And the way, so I have this value I that's 2. So I can do, this is a template literal, and I equals, and then I surround the variable with $sign braces, and you see it interpolates the value of the variable 2. Very, very handy. I can do this I is less than 0, and it interpolates false, like you can see here. Strings have a length property. In JavaScript, you will find that a lot of the things come as properties or methods as opposed to being built-in functions. There are, I think, extremely few built-in functions in JavaScript. Almost everything is a method. This is in contrast to something like Python, where to get the length of a string or the length of a list, you have to do len and then in parentheses that thing. In JavaScript, you do backwards. You have that thing, and then you do dot length. So if I do const b equals, let's just make a string, and then I do b length, just like that, we get 28. So I type 28 characters of gibberish, and I can access specific values using bracket notation. This is 0 indexed. I'll explain that when I get to arrays. They also have a split method for chunking up strings into arrays, which we will not be working with. Oh, by the way, yeah, go ahead.
For length, for each string, does it store a length value at the beginning of the string, or does it actually calculate it through each time you call the length parameter?
That's a great question. So because the string is immutable, because of using the const keyword, it would suggest that it's calculated when it's defined, or when it's assigned, when it has the value assigned to it, but I don't really know. The other way of answering that question is people don't use JavaScript for speed. So like these kinds of optimizations are like, you would want that kind of, like that's why in Java, when you create an array, you give it a set length, because then you gobble up that amount of memory when you declare that array, which makes Java run really quickly. JavaScript, we don't really care about those kinds of optimizations when we're using JavaScript. So yes, but this is perhaps one value of using immutable variables, is that you do calculate that stuff ahead of time. I'm not sure that there's a way that I can add stuff to this and thereby change the length. I could be wrong. Booleans, true and false. These are tests that you can just type in. Is 2 less than 1? False. Is 2 equal 1? False. Is 3 less than or equal to 3? True. 1 or false? 1. Why is the answer 1? Yeah, false would be 0, but this is, I mean, the OR operator just takes whichever is the first true answer and just returns that. So if I do false or 1, I get 1 again, because it just skips the false. I mean, this is like a little bit silly. Now it gets really silly. False or 0, triple equals false. False. False or 0, double equals true. Any guesses? This is like really nerdy stuff. One of the good parts of JavaScript is the triple equals. The double equals is not a good part. The triple equals requires it has to be the same type. The double equals, things don't have to be the same type. I think that's right. So if I do 1 double equals true, I get true. If I do 1 triple equals true, I should get false. Yeah. So the recommendation is to because type coercion in JavaScript is idiosyncratic, you are recommended to always use triple equals, so that you always are using, so that you're not surprised by weird type coercion. If this is like totally over your head, don't worry about it. When you're comparing two values and want to see if they're equal, use triple equals. Double equals will give you unexpected results. And the triple and equals and double equals, that tests for equality. The single equals is the assignment operator that gives a value to a variable. So const a equals 1 means declare the variable a, assign the value 1 to it. a double equals 1 asks the question, is it the case that a, the value that has been assigned to a, is equal to the number 1? True or false? These tests are used in things like if statements and while statements. We will look at those in a second. All of these have, in the presentation at the bottom, they have this little link to the MDN documentation. MDN documentation is Mozilla Data Network, I think, documentation. It's just a place to go read something resembling the full description of all of these data types. OK, arrays are like lists in Python. They can have anything inside of them. So unlike a Java array, which can only have things of one type, or a vector in R, which can only have things of one type, in JavaScript, an array can have anything in it, including other arrays. They are surrounded by brackets. They are zero indexed, which means the first member is indexed 0. The second one, so this is why I tend not to say first and second. I tend to say 0th and 1th, and then 2th and 3rd members of the array. That can be a little bit confusing. They have a length property instead of using the length function as before. Filter, map, and reduce methods. We will talk about these in a second. These are the hardest things that I think to people who have no programming background, these are the hardest things for them to kind of wrap their heads around. So I'll try to go slowly and make sure everybody's on board. And they also have a join method for if you have an array of whatever and you do join, it smooshes them all together into one string. So that's a handy way if you have like a list of names that you're inviting to a party and you want to turn it into a comma separated string to say like dear blah, 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 and blah, blah, blah. You can use join to smush those together. Objects are like dicts in Python. They can have anything inside of them. The main thing here is to see what they look like. So this creates an object called foo that has two properties, an A property and a B property. The value of the A property is 1. The value of the B property is 2. You can access the property either with bracket notation, this is how you do it in Python, or with dot notation, foo.a. I don't think that works in Python. I'm pretty sure it doesn't. Everything basically in JavaScript is an object, even if it doesn't look like it. So, but compared to other languages, these seem like a POJO, a plain old JavaScript object, is a data type that you see a lot more in JavaScript than I would see in other languages that will very quickly create classes and have inheritable methods and properties and all this sort of stuff, whereas in JavaScript everything's a little bit loosey-gooseier. JavaScript does have classes, but the inheritance is a little bit weird and unexpected. Yes?
Yeah, so for objects, does it have to be key value pairs or can it be everything?
So I have key, so they are key value pairs in the sense that the property has a key and then it does something, but you can have methods if that's what you mean.
Okay.
So I can have something like, so let's do const foo equals, let's do A is 1, B is 2, and then let's see if I can remember the syntax. I don't think this is right. There is a way, I can't remember off the top of my head how, but you can create a function. And so when you have something like, I just don't want to mess it up because I can't remember exactly how the syntax goes. But like filter, map, reduce, join, these are all methods that are defined within the prototype array object, like this. So if I were to do array, like I could create a length property that is 1, and then I could create a a join method that does like, do stuff to join it together, et cetera, et cetera. So in that sense, it's not just key value pairs. I think that that's the addition of methods sort of makes me think that that messes things up. But the value can be anything. It can be an array. It can be another object. It can be, or like I tried to show here, a function. Was there a question over here? No? Oh, sorry.
How do you create a function inside an object? Like, how do you write each part of it and then write the return statements?
Yeah, okay, I'll just look that up then. Because they changed the syntax a little bit. So let's do write a method in JavaScript. Da, 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 da. No. No. Okay, we can use probably the old syntax. This is what that's what they're suggesting here. Okay, so let's do this way. I'm going to hop over to objects, and did I end up creating a foo? No. Okay, const foo equals a colon 1, b colon 2, and then for c colon function bar bracket, and then return bar is bar. And then close that, and then close that. Okay, so now I have this object foo. If I do foo.a, I get 1. Foo.b, I get b. Foo.c, I should just get a function. There you go. But if I do foo.c and then put in a value for bar, like bingo, I get bingo as bar. So this is the slightly older syntax for doing this. I know if we'll get to functions in a second. This is the standard syntax. About 5 years ago, they updated how you do the syntax, and I can't remember that off the top of my head. It's something more like C bar, but I don't know if it's an arrow function or not. I can't remember, and I don't want to break things. But that's one way that definitely does work. Okay, so on that subject, let's jump to functions. They can be named. This is like using def in Python, where you have a named function. Or they can be anonymous, which is a little bit like lambdas in Python. Anonymous functions are extremely idiomatic in JavaScript, to the detriment of many a developer who has to debug things. What an anonymous function means, and the way, so the normal, a function will have 3 parts. An optional name, obviously, well, not obviously, but an anonymous function will not have a name. An argument parameter list that's surrounded by parentheses, and then a body that's in a block that's surrounded by braces. So this is an example of a function. All it does is it takes a parameter and returns the same exact parameter that you sent to it. So you define it with the keyword function. It has the name my function. It has one parameter x, and the body of the function is to return the value of x. That's it. To my eyes, this is not idiomatic JavaScript. In idiomatic JavaScript, you would write this as an anonymous function and assign it to a variable called my function. It's a very subtle distinction, but you can see that it's written differently. I declare a variable called my function, and I assign to it an anonymous function, so it has no name. It's just function parentheses, function x, return x. They're not identical. But it's close enough. And this feels to me idiomatic. Even more idiomatic is the arrow function shorthand, which I fight myself every time about whether I should even mention it, because it is so terse, but it is even more idiomatic, which is const my function looks the same. You skip the whole function word, you just have this x out of the middle of nowhere, a completely undefined, undeclared variable called x, an arrow, and another x. And that's identical to the other two functions. It's an extremely terse but very idiomatic way of writing functions. I will talk a little bit more about that as we keep moving. So far, so good? OK, great. All right. Functions let us talk about the array methods. So I said there were these three things that I do want to, how am I doing for time? Oopa. There are these three things that I do want to go over. Hopefully, many of you will get the hang of them really quickly. If you don't, that makes sense. They are very complicated. You just have to keep doing it. So what I'll do is, I can't call it A because I already have an A, I think, here. Yes, so const AA equals, I'm going to just make an array called 1, 2, 3, 4. And if I just show it, you can see it's an array with 4 values, 1, 2, 3, and 4. The 0th value is 1, 2, 3, 4. First, filter. What do you imagine filter does?
Filters out elements of the array.
Yes. So, well, you give it a condition, and it only keeps the members of the array that meet that condition. So the way this works, the way the method works, if I type filter, does it give a little helper thingy? Oh, no, it's AA filter. So you can see it gives the little helper message here. It's asking for a predicate, and this arg, skip this arg. The predicate is what we call a callback function. So it's just a function. And now this is when you maybe start to see why anonymous functions are so common in JavaScript, because you're nesting a function inside of a method. You're nesting a function inside of a function. So the function here would be, one way of writing it is function n. What is n? Just an arbitrary variable that I define here that is each individual member of the array. So the first time through it's 1, the second time through it's 2, the third time through it's 3, etc. Function n bracket n, let me write this out correctly, n triple equals 2, close this, close this. And I get, as a response, an array that has only one member, that is the number 2. The way I've written it here, it's the exact same thing, but using the arrow notation. So this n, does anybody have questions about what n is here? Excellent, you're all pros, I guess. Map. Does anybody know what what map does?
Look,
Go ahead.
just look, yeah. So
Yeah.
It's in plus, so it's yeah. So that will return 14916.
Yes, exactly. So map, it returns a new array that's the same size as the previous array. This is a mistake that I've made in the past where I've tried to use map and then been like, if it's this value, return it. If it isn't, move on to the next one. What you end up is an array that's the same length with a bunch of nulls. And then yeah. But so you get an array that's the same length, always, always, always the same length as the previous array, but with some kind of adjustment made to it. So here the adjustment is multiplying the value of that step times itself. So again, this is all tricky. If you have questions about this and want to ask me at some other time, that's perfectly fine too. Reduce operates a command across all of the values of the array and smushes them together. If you've used a group by in R or Python or something and then done sum or mean or anything like that, that's what happens here. So for example, this here, what this does is it takes n and m. One of them is the current value of the array. I think it's the first one. And the second one is the rolling subtotal. And then it adds n, the current member of the array, to the rolling subtotal. So that's the function, the callback function. And then 0 is the initial value. So this returns 6. Or no, not 6. I have 1, 2, 3, 4, so 6 plus, it'll return 10. So again, this is tricky, but these sorts of things also come up when you start doing data analysis. So this is filter changes the size of the array, map keeps the array the same size, but does something to every value, and reduces the array to one value. That is a mean, a sum, something else. Sort works this way too. It also sort expects a callback function. I'm trying to remember which one of the sorts doesn't work like you would think it would. Like I think sorting by number is hard. It doesn't work like you would like. Anyway, okay. So null. Let's skip blocks. So this is pretty straightforward. For loops feel to me extremely non-idiomatic. I'm not entirely sure why. They just don't feel idiomatic, but this is what they look like. Oh, I wanted to just the usual let I equals, so there's the let keyword because I changes every time you step through. It's added by 1. You can use the double plus operator instead. And for each feels a little bit more idiomatic, but I would actually just always use map. Because if I'm doing a for each, I don't necessarily care about the returning, or I would set it to a new array or something like that. But for each basically works like map. And as you can see here, it takes a callback function also. Functions inside of functions. This is the JavaScript way. I am going to skip this for now because I wanted to get us to doing things. So we'll do this in Observable instead, which is to write a function that creates a tip calculator. Observable. Observable notebooks were created by the same person that created D3. If you are doing a lot of data visualization in JavaScript for the web, typically, you will run into using D3 almost certainly. They are like Jupyter Notebooks, but for JavaScript, and they open up the possibility for doing things like exploratory data analysis with JavaScript, which is a very weird thing to say because people typically think of JavaScript as a toy language that just makes web pages annoying. But you can use it for a lot of stuff. So I created an observable notebook that I encourage you all to go to now. So you can use this thing without signing in or signing up. This is a live web page that you can edit to your heart's content. You can change the name. You can have this link point to wherever you want. You can do whatever you want with it. So I'll wait for a second for you all to open this up. The link is available here at the bottom of this slide. Who has it open? All right, you all move very quickly. Who has familiarity with Jupyter Notebooks? OK. So for those of you that don't have familiarity with them, this page is made up of things called cells. So you can sort of see the cells here on the side. If I click this, you see the rendered. Let me zoom out a little bit. You see the rendered version of the cell and then the code behind the cell, one on top of the other. If I close this, then you just see the rendered version. This is Markdown that I mentioned a little bit earlier. We won't spend a bunch of time with it until later in the semester, but that's where it is. In Jupyter Notebooks, you expect them in the opposite direction. The code is on top and the presentation is at the bottom. In Observable Notebooks, they work in reverse. And if you make a change, it doesn't kick in until you do shift return. And then it kicks in. It says hi now here. Like it says here, if you want to save these changes, you should be signed in. But you won't have write access anyway, so I don't know. You can have at least three different kinds of cells, Markdown or HTML or JavaScript. So we're going to stick to JavaScript. I have here a link to Observable's own Introduction to Observable for Jupyter users. It's really good. I think in 2 weeks, when we talk about doing data wrangling in Observable, I will go through this at the beginning. So to create a new cell, you click on the plus, and then you pick JavaScript, Markdown, or HTML. Oh, I guess you can do other stuff too. Oh wow, I'll have to look at this later. This is a JavaScript cell, and you see that it looks a little bit different than what I've been saying that we do in the past. How does this look different than what I was showing earlier?
There's not the cons.
Exactly, yeah. So this is the first way that observable notebooks don't have actual, like, it's not exactly JavaScript. It's a little bit, it's a superset of JavaScript. What this syntax does, and I think I'm right to describe it this way, is you are naming the cell my total, and then you're assigning a value to it. So it's not exactly a variable. It's the result of the cell. And this is one way that observable notebooks are very different from something like Jupyter, because in Jupyter you define a variable and then you have it just available whenever you want in later cells, and you run them all at the same time. That is not the case in Observable. It runs everything at the same time. So as soon as you name a cell, the value in that cell is available even in previous cells. So if you go to Observable Notebooks, you'll often see like they open with a map full of data. And it's like in Jupyter, you would have to have pages and pages of doing things, or cells and cells and cells of doing things, manipulating, moving, all this sort of stuff. And at the bottom, you get a pretty picture. On Observable, you can start with the picture. And then the code is all at the bottom in an appendix. So here I created this thing called myTotal, and I gave it a number. You can change it to whatever you want, and then just do shift return, and it just says my total equals blah, blah, blah here. Now you see I have this cell here where I do my total times 3, 70.41. If I change the value of my total here, this changes to 60 immediately. And just for laughs, let me put a cell above it. That's my total times my total, 400. Let's change it to 2 here. Now it's 4. So JavaScript is magic. What can I say? Yes?
So does it mean that everything is global? So the only local thing will be inside the function?
Yes. So sort of. It's no. That's a very good question. I was thinking about this morning, and hoping somebody wouldn't ask because it's complicated. The sort of way to think about this is when you're defining, and I think this is right, when you're defining variables in a Jupyter notebook, you're just polluting the global namespace with whatever because you can define df in one cell and then redefine it again in a different cell, and then you don't know which df you're dealing with anymore. A cell in Observable returns one value, only one value, and that is what is indicated by this my total equals blah, blah, blah. I can create a block like this, and it'll still return 2. And I can create inside this block, I can do whatever I want. I can use things like const a equals, some number, const b equals some other number, and then I can return a plus b. I'm going to hope this works, actually. I'm not positive. But yeah, it works like that. Because the the way of thinking about it is that you aren't creating global variables. What you are doing is each cell only returns one value. So you think of each cell as doing a specific move, whereas in other types of notebooks, or if you're typing code, you'll have like a function here, a function there, a function there, and at the bottom you'll have like a, if main, do all this sort of stuff, like the launching method or whatever. In JavaScript, in app development in JavaScript and so on, it's really gotten to be popular where every class is its own file. Sometimes every function is its own file, like very, very, very modular. And so that's how you get this. So let me change all this back to normal looking numbers. I don't want anybody to think that I go and spend $2,600 on dinner. 22 sounds good though. Okay, so tip calculator. Two parameters, total and service quality. I want to return how much I owe in tip. How do I do this? Now I turn this sort of over to you. Tell me how to do this. Let's have some fun. So I first off, what's service quality? Other than a variable. What kind of variable is it? Is it, go ahead.
A categorical variable?
Sure. So we want to make it a categorical variable. What are the possible values?
1 through 5.
What's that?
1 through 5, like the integers 1 through 5.
Okay, so then it's numbers.
But like, it's like so subjective though.
So like a Likert scale, yeah. Okay, so we pass it as, but do we pass like good, or do we pass 1, or what are we passing into the function for our service quality? The numbers?
Yeah, I guess
Whatever you want.
Yeah, sure, the numbers.
Okay, the numbers. Okay, so service quality is going to be a number. So in like TypeScript, we would write this, like number, but we can't use TypeScript in here. So, all right. So how do we break down, what effect does service quality have on how much we're tipping? I'm assuming 1 is bad, 5 is good, and everything in between. So what effect does the service quality have on how we're tipping?
At which percentage, or do we
Yeah.
have to assign like
Sure,
a
sure, sure.
numeric number, like a numeric value to it? The 1 is 2%, the 2 is 4%, or no?
Yeah, if you like. Yeah. No, that's perfectly fine. So well, how do we write that in code? If service quality equals 1, then we set some kind of value for the tip, right? You said 2%?
I'm European, I'm not used to tips. So
Yeah.
like for me, everything is so expensive, I would tip 2%.
Yeah, the American response would be, if the quality is bad, what you are doing is you are adding 2% to 15%.
Oh my gosh.
So what we can do then is return.
The total is already 15%.
No, the total is what you owe, like $20 for your
The total is like the
cheeseburger.
price.
Yeah. So we return 0.15 plus, or well, we can put it this way. Return 0.17 times total. Right? So it's a 17% tip. That does sound kind of high for one service, but whatever. Okay, what if the service quality is 2? Anyone?
Total times
0.19, excellent. If service quality equals 3, let's stick to 3, just to 3 values, just to save time. What's the value here? 0.2? Okay, 0.2 times the total. So a maximum of 20% tip. And then if there is no service quality, there is no tip. So we just return total. That's our default. that's great. And then if down here we do tip calculator my total. Oops, so I do shift return. And then when I do tip calculator my total, why do I get this value? Why do I get 22? Oh, because I didn't pass in a service quality. There we go. The tip is 4.4. Oh, so we return 0, not total. No tip. All clear? So far, so good. Can we make this code shorter?
Yeah.
How? Let's refactor.
Is it a switch function
There, we could use a switch. What I would do is I would do create a variable called something like service percentage. That's an array of 0, 0.2, 0.4, and 0.5. And then do just do service quality equals 0. So you can do an equals in here to make it the default value. And then just return service percentage, service quality times total. Service quality is with a capital Q. Now, why did that not work? Why do I get 11 now? Oh, because these are... return service percentage. See, this is fun. Plus 0.15. There we go.
That's actual, yeah.
What's that?
Yeah, that's the actual, right? That's you need to add on to the point.
Yes, because we have to add to 0.15 because we're not in Europe. We can't just tip 4%. We have to tip 19%. So yeah, so this is. Does someone want to explain what's happening here? How I was able to collapse what we had, which was like, I don't know, 10 lines of code to 2? Go ahead.
I guess you're accessing the value of the list that corresponds with the service quality and adding it to 15 and multiplying it by the total.
Right, exactly. So we because you chose to have the service quality be an integer, we can create an array where each index of that array corresponds to one of the values for the service quality. And then we can assign a percentage that we can either add to 15 like I did here, or we could just skip the adding 15 and just add 15 to all of these anyway. So actually, if the service quality is 0, you give a 15% tip anyway. There's no nothing. So yeah, so if I do 0, I have to pay 3.3 on a $20 bill, no matter what, or $22 bill, no matter what happens. So hopefully you saw how quickly this like updates and all this sort of stuff, and it's kind of fun. And then I don't know. Do you want to do the next challenge? Was this fun? You want to do the next challenge? All right. Leverage tip calculator above to create a function that takes an array of diners and tells each diner how much they owe in tip, and then tells us the full value of the tip as well as the table-wide sense of the service quality. Hint, define a diner as an object with name, total, and service quality properties. Well, that's a good hint. I should know I wrote it. How do we do this? So let's create diners. What did I say? Array of diners. So I'll make a blank array right now. What goes in the array? How many diners should we have? 3? All right, let's have 3. What kind of data type goes inside the array? I said define a diner as an object. So let's make 3 objects. which we make with the braces. So now we have an array that's 3 items long, object, object, object. And then I said, give them all a name. So let's have, in classic style, Alice, Bob, and evil Charlie. Okay, so now we have our 3 diners. Each of them has this different name. And if we see, by the way, the syntax here that you see in this sort of like upper thing looks exactly like how these things look in the console. It's a very funny, it's a wonderful coincidence or whatever. So we can see we have 3 objects with these names. So then what did I say? Total. What is Alice's total? How much did she spend? How much food did she order? Just shout out a number.
20.
20? Okay. How much did Bob order?
50.
50? 50? Okay. And Charlie?
45.
45. Excellent. Okay, now service quality. What did Alice think of the service? This has to be 0 through 3. 2? Okay. What did Bob think of the service?
0.
0? There's always 1. And what did Charlie think of the service?
3.
3. Okay. So now I do shift return, and now we can see that we have an array of these 3 objects. Okay, so now you may be inclined to now do the rest of the code still in the cell. But no, this cell defines and returns the diners array. So we don't have to, so now we move to a new cell that we make with JavaScript. And now we do the function. So what did I say we have to do here? Create a function that takes an array of diners and tells each diner how much they owe in tip and tells us the full value of the tip. Okay, so we will use, I was a little bit silly about this because I can't now remember exactly if I can do console log here. Nope. Print. Blah. Nope. This was a funny thing to forget to double check beforehand. And it's not letting me open up the console either. So let's quickly figure out how we can use observable print or return string. We'll just do it that way. This is it'll be a little bit more complex, but that might be fun. Unless it actually spits something out here. Yes, so it did actually spit something out here in the console, but I have a more fun way of doing this. Okay, so let's create a function that, so we have the tip calculator function, so it tells each diner how much they owe in tip. So we're going to iterate over the diners map. And let me just make sure that this works. Okay, so if we iterate, things get a little bit complicated here. So we can just iterate over the diners and get their 3 names. So I do that here like this, with n.name. You may have a little bit of difficulty. Can you reach that?
Pass me the plug.
Okay, so for each diner, we're going to do something. So let me not use the arrow functions. Let me just do this the old-fashioned way. Okay, what do I do for each diner? You tell me. Tells each diner how much they owe in tip. So we need to know how much they owe in tip. So we can do const tip equals, what does tip equal?
Tip calculator.
Tip calculator. What's the total?
And name. Or
N dot total. And what's the second argument that we send to the tip calculator?
N dot service quality.
Yeah, exactly. And what do we do with tip? What does it say here? Tells each diner how much they owe in tip. So we can just do return a string that says n.name, you owe tip in tip. Easy peasy. The money isn't formatted exactly correctly, but we don't care.
So
Or I
the
don't
first
care.
dollar sign is a little bit.
Yes, the first dollar sign is just inside the string. It's the bracket that starts the that calls the interpolation. Yeah, good question. So are we done? And tells each diner how much they owe in tip. Yes, and tells us the full value of the tip. So how much the tip is in total. How do we do that? That's a great idea. It would be complicated to do it that way, but I think one thing we can do is we can abstract this out as a function. So let's just take this part here and create a new function called tell diner. Okay. And okay. So now we have, I abstract this out to a function. And then what I can do is I'm going to keep this cell up here. So for the time being is I can do diners, map. And I think I can just write tell diner, just like this. Diners. Yep. Okay. So does somebody want to explain what just happened here? I took up here diners.map means we're going to iterate over the array of diners and do something with each member of the array. This is where using map, like for each, might make more sense because for each diner do da 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 da, whereas map is more like recalculate something on the fly. It just map is fewer things that I have to type. So map takes a callback function. And so I wrote this anonymous function here that takes the tip from tip calculator, passing in the total and service quality properties. And then it returns this string, name, you owe, tip, and tip. I pulled this function out and created a named function called, well, close enough, a named function called tellDiner that does the exact same thing. And so now instead of passing in this anonymous callback function, I can pass in the named function and I get the same exact result. So now I can delete this I can delete this cell because we don't need it anymore because we have tell diner doing that. So now we need to know how much the total tip is, right? So what we can do here is we can make a new cell, because I know that time is tight, and we can call this total tip. And how do I do this? What should the first?
Total tip among the table.
Yeah. So how do I start this? Zero. But how do I extract the tip from? Oh, I can extract it from tip calculator. Sorry. So I can just do diners, map. Well, let's do for each because it might be a little bit more idiomatic. Tip calculator and total and service quality. I had an idea about like extracting this information from the tell diner function, but we don't actually need to do it that way. And then, oh no, we want to use map. Oh no. Sorry, this is a little bit messy, but it will make sense in a second. Exactly. Or, you know what? Let's even be sillier. All right. Is everything lined up? Yes. Nope. Rats. Okay. Oh, of course. I don't have a return value. There we go. What's happening here? I know this was super fast.
You're like iterating over each object in the array and like adding it to a counter.
Yes. Yeah, exactly. So reduce would have been one way to do this. Doing it with reduce would have been kind of funny because we would have written an entire function and then done dot reduce on the return value, which would have been the array. This is a little bit, I don't know, like a little bit more straightforward perhaps. But the idea is, yes, we start a counter, total tip. That's why we have to use let, because we change the value of total tip every time we step through the array. And then we have diners for each. For each is basically, now I can see where the differences are with map, but it just does something to every value. It uses every value of the array. So it steps through every single one. Every single time it goes through, we set the value of total tip to the previous value of total tip plus the return value of tip calculator for that diner, n. Let me even change this to diner from n to make it a little bit more. Like this. Oh, nuts, I used arrow functions. Sorry, I'm bad. Okay, so this is no longer using the arrow functions, but does the same thing. Okay? A quick little thing. Do you know what object destructuring is? It exists in other languages. I actually don't have to even use diner here. I can just do total service quality, and it automatically extracts those properties from the diner object. So these are reasons why you want to have well-structured data because it has predictable properties that you can use object destructuring to do this sort of thing. So instead of, it's not that big a deal to do n and then, but I don't know. I prefer doing it this way. All right, so we had one step left, which was tells us the full value of the tip as well as the table-wide sense of the service quality. Okay, so this should be just diners. Oh, we can use reduce here.
Yeah.
So diners reduce, but now I will have to remember which is diner and which is initial value, which I think this is the order. And let's make the initial value 0. Wait, how do you use reduce to get an average? I know how. Average quality equals block sum of quality equals diners reduce diners init so diner service quality plus init. Is that right? Yes, looks good. Then let's just return average quality. This won't be the average yet, but just to make sure that I'm writing the reduce correctly. Circular definition. Oh, sum of quality. Yup, and these are backwards. Ah, boy. Maybe I don't use the reduce. Yeah, let's not use reduce. All right, so the average quality is, let's do this the old-fashioned way, const sum equals 0, and then diners for each diner.
Sorry, would it have to be let sum be 0, not const?
Thank you very much. You are correct. For each diner, sum equals sum plus diner service quality, and then return sum divided by diner's length. Please work. That looks good to me. So there we go. I thought we would do this all in one function, but it actually feels better for Observable to do it spread across a bunch of cells. All right, that's all I had. Thank you very much for, I'm a little bit over. Thank you for participating in this part of this live coding. I don't, in the future, I don't know that we'll be going this quickly and this sort of stuff, but I hope this was sort of elucidating, and it'll be much more exciting because we'll do like interactive stuff and whatever as we go forward. Although this was kind of interactive too, at least for me. All right, and again, if you only remember one thing, data@library.columbia.edu. And other than that, good luck this semester, and come back in 2 weeks if you like. We'll be working with data. Do you want taxi data? All right, let's work with taxi data. I'll have to figure out how to make that available. That's my Pandas workshop always uses taxi data. So, okay. Thank you very much.
Is there something we can read before the class? I felt like I am not like that up to date with.
Yeah. So I think no, that's a great question. I think this.
That link, okay.
Yeah, this link, or in general any. So we're going to be using Observable for almost all of the rest of the semester. So getting a good sense, and this is for me too, because I am very eager to get better at it. I'm not very good at it. I have to, like, I don't know how to print stuff to the screen. But it's something that I'm very interested in because I like JavaScript so much. in comparison to Python and R, which are the languages that I have to use in a more professional setting. So looking at their tutorials will be helpful. If I moved, like, as far as the syntax, look up something on arrow functions. Maybe I'll have a little bit of something to describe them, unless they're completely transparent. I don't know that they are. And that's about it. Okay? Grab a sticker if you didn't. Remember, or actually grab two, like I said at the very beginning, because they have a mistake. So they will be worth something in the future when Data Club is world famous. The next batch does not have the mistake, and the next batch is coming next week. So I'll burn all of these, so they'll be even more rare.